Sunlight and Showers, Part 2. As you read the second half of the book, you are going to be reading to think about what are some of the things that engineers do that are mentioned in the book. What page number do you see it on? And then think about how that compares to things that we do in our own science class as electrical engineers or just engineers. As we read, I will start making some notes, which are things that you can use to help you. The first thing the team did was investigate or learn about the problem they wanted to solve. Some of the students went to Guatemala to learn from the people there and better understand their needs for hot water. The students talked to a lot of Guatemalan people. They found out how much hot water people needed and what they would use it for. So I'm gonna take my Post-it. I'm gonna make a note that says, investigate, page 10. They asked people what times of day they would use the hot water. They asked to see people's houses and talk with them about where to put a water heater that would be safe and easy to get to. They wanted to build the water heaters in Guatemala, so they found out what kinds of building materials are available there. They wanted to make sure Guatemalan people would actually find the solution useful. So I'm going to add to my list, ask questions, page 10, and find materials, also page 10. The students went back to the U.S. and shared what they learned from the people in Guatemala with the rest of the team. The team thought about the needs of the people they had talked to. They thought about how to design a water heater that would meet those needs. There were several criteria that their water heater would need to address. The water heater needed to heat 100 liters, about 25 gallons of water, to a temperature of 40 degrees Celsius or 104 degrees Fahrenheit. The water heater needed to be easy to build with materials that could be found in Guatemala. It also needed to be cheap to build and to put in people's homes. It had to work without costing extra money for the families who were using it. It had to last a long time without breaking down. The team thought about all of these criteria as they planned their water heater. So I'm going to add another chart that says, consider the criteria. And that is on page 11. Next page. The team investigated lots of different materials for building the water heater. They wanted to find out which materials would keep the water hot by holding in the most thermal energy. After gathering all of this information, the students made a plan and began to build different water heaters. So here, I could add another little note. Made a plan, page 12. To test the materials, they built water heaters out of each kind of material. Then they put the water heaters in the sunlight. They measured how hot the water got and how long the water stayed hot. They tested heaters made of wood, cement, foam, metal, and other materials. Then they synthesized everything they learned, putting it all together to decide which materials would make the best solar heater. So here I would say another one was test. Another one would be measure. Another one would be synthesize. See if I can do it with my hand holding the phone. Synthesize. And these are all on page 12. Wood was one of the first materials the students tested. It would have been easy to build the frame of the water heater out of wood, and wood didn't cost very much. However, the students talked to people in Guatemala and learned that wood is not the best material for building there. Even though it is sunny most of the time, there are lots of heavy rainstorms in Guatemala. So the wood would often get wet. After a while, wet wood becomes rotten and falls apart. Wood was cheap, but it wouldn't last long. The team had to think about trade-offs such as this as they were testing different materials. They thought about how much materials cost, how easy they were to get in Guatemala, and how well they worked. So another one, consider trade-offs. 13. Here's the solar water heater, made out of black metal, glass, a plastic bag with water inside, foam to hold in thermal energy, pipe that let out hot water, here, pipe that lets cold water into the heater. After synthesizing what they had learned from all their tests, the team decided to build the heaters out of metal. Here's how the heater design works. The water is in a plastic bag inside the heater. On top of the plastic bag is a sheet of metal painted black, and on top of that is a sheet of glass. Glass lets a lot of light energy pass through it, but keeps in thermal energy. The sunlight goes through the glass and hits the sheet of black metal. The sheet of black metal absorbs the light. The metal is painted black because dark things absorb a lot of light. When the light energy is absorbed, it is converted into thermal energy, and the metal gets hot. The water underneath the metal sheet gets hot too. Foam around the bag of water helps hold in the thermal energy to keep the water hot. The metal, plastic foam, and glass are all cheap materials that are easy to find in Guatemala. This design met the criteria of being simple and easy to build. Solar shower. The heater is attached to the roof of a house. There are two reasons for this. First, the roof is outside in the sunlight. Second, if the heater is on the roof, the hot water can flow down into the shower. To take a hot shower, you can turn on a faucet attached to a pipe that lets water into the bottom of the water heater. The hot water at the top of the water heater is pushed out and comes down another pipe to the shower. The new water that was let into the bottom of the water heater now gets heated for the next shower. Cold water comes in the pipe from a holding tank. Pipe that lets cold water into the heater. Solar water heater, light from the sun is heating it up, and it comes out hot. The team tested their solar water heater many times at the lab in the US. Each time, they measured the temperature of the water to see how long it took to get hot in the sunlight and how long it stayed hot after the sun had gone down. Once the data showed their design would meet the criteria, they were ready to try it out in Guatemala. So on this page, I'm gonna write collect data. Members of the team went to Guatemala again. They used their design to build solar water heaters with the materials they could find in Guatemala. They worked together with families to set up the water heaters on the roofs of the families' houses. The families tested the water heaters and found that they worked. The next step would be for Guatemalan people to make more water heaters so many more families could buy them. It took a whole team of engineers working with many people in the community to design the solar water heater. One team member, Sarah, said, "I don't think it would be possible to do this on your own." Everyone on the team was an expert on something different. Some knew about designing things, some knew about energy, some knew about different kinds of materials. Because the team members knew about different topics, they were able to think about their design in different ways. They also learned a lot from talking to people in Guatemala. Working together, they figured out how to solve their problem. Hey, that's another thing that you guys do. Work together. The students say Professor Gadgil's class is one of their favorite classes. Professor Gadgil is proud that his students are learning how to solve real problems for real people, and the families in Guatemala have a solution that helps them get hot water. One team member, Alyssa, said that using science to solve a problem in people's lives was the best feeling in the world.